So, just to get us back on track, we need to explain what an applied force is. An applied force is basically just the force that you apply to an object, so it can vary in strength. Unbalanced forces are when the object is changing speed, which is basically accelerating or decelerating. Balanced forces are when the object is moving or not moving at a constant rate. Friction occurs when an object is moving against another object and it decelerates the object. There are many different types of friction, which include rolling friction, sliding friction, static friction, and fluid friction. Gravity, which you hopefully know what that is a force that attracts every object together. The more mass an object has, the higher attraction it has to other objects. The Earth is the source of gravity for human civilization and is the cause of objects falling down in the demonstrations. Finally, inertia is the thing that makes it so that objects have a tendency to not want to move. These vocabulary words may be used during future demonstrations, so totally don't forget. I know that I don't have to do this, but...
Hey guys, Newton's first law is totally tubular. Here's all that you will need to know about it. Newton's first law is an object at rest or in motion will remain at rest or in motion unless acted upon by an unbalanced force. This means an object that is moving won't change speed unless acted upon by another force. The demonstration I will be showing you today involves this ball and this hand. So, as you guys saw during my tough demonstration, when I left the ball alone, it didn't move because it was a balanced force. But when I hit it with my hands, which was an unbalanced force, the ball started moving because objects will not stay at rest or at the same motion when acted upon by an unbalanced force. According to Newton's law, of course. Now time for the second example. As you guys saw in my oracle example, the ball was in motion and it was a balanced force because it was staying the same speed. When it came in contact with my hands at rest, my hands changed its speed, making the ball go a lot slower in the other direction, which was an example of an unbalanced force, which was another example of Newton's first law. Now for the third example. This is a different sigma kind of example of Newton's first law, because instead of talking about how objects staying at rest or motion, it describes inertia, which is another part of Newton's first law. The ball wants to stay in place due to its inertia, so it doesn't move with the hand. But the ball is still quite light, and it has a low inertia, so it moves toward the direction of the hammer with less force. Finally, our last example is here. I got a new ball now.
No, he doesn't. Oh, wait, he does. They couldn't even see your thumbs up. This
shows another totally fantastic property of Newton's first law, which is friction. There are many types of friction, but this one is rolling friction. Because rolling friction is when the object rolls, which in this case, the object does. The ball slows down because of the friction between its rolling and the table, and that is Newton's first law of motion in a nutshell. But that's just a theory, a game theory.
Isn't that not a game theory though?
Hello, continue to help me demonstrate Isaac Newton's second law of motion. First, I'll be applying force onto both of them. This was applied force when you push something, or someone or something pushes something else. So, as you can tell, Timmy the Tiger went further than the book. This is because Timmy the Tiger is a lot lighter than the book. And the book is heavier than Timmy the Tiger in turn. So, it will take a lot more force to push the book rather than Timmy the Tiger, the little tiger. and since I had pushed them with the same force, then they were both. We will see you next time on Timmy the Tiger Learns, also sponsored by Refugee.
Hello guys, in this segment I will be talking about Newton's third law of motion. Newton's third law of motion says that for every action force there is a equal and opposite reaction force. That brings us into the definitions. An action force is when an object acts upon another object, but a reaction force is can you just cut this part out? A reaction force is a reaction force is a reaction force applies this equal amount of force as the action force, but it's going in the opposite direction. That applies for pretty much everything. Also, the guy behind the camera is stupid. Since I'm a little lazy, I'm gonna do a basic demonstration of Newton's third law. As you can tell, the ball on the left rolled and hit the ball on the right, the action force, an object acting upon another object. But the ball on the left for some reason stopped. That was because of the reaction force that the ball on the right applied on the ball on the left.
Go.
I'm open! Open, guys. Can I catch Timmy the Tiger?
Timmy!
No, did I needed my strength.
I'm down.
On the left.